Today in our lesson, we will be solving or answering the essential question of how do we identify congruent figures? So in the last couple of lessons, we have been looking at different transformations. We looked at translations, which were a slide. We looked at a reflection, which was a flip over a Y or an X axis. And next, after that, we looked at rotations, which was spinning either clockwise or counterclockwise. All of these different types of transformations are called a rigid motion. So that means that when we are moving, translations, reflections, and rotations, those movements that we're doing preserve or keep the length, angle measures, shape, sides, everything like that the exact same. All we're doing is we're changing the figure to be in a different location. So a really important vocabulary word for us to know is called a rigid motion. And like I just said, a rigid motion is a type of is the transformation that preserves length and angle measure. So these are the transformations that preserve length and angle measure. All right, we call these rigid motions. The shape itself is not changing, only the location. So we're preserving the length and the angle measure. The types that we talked about that do this, the types of transformations that we've looked at, the examples, are translations, reflections, and rotations. All right, so we use these types of motions to move figures from one place to another. The idea around preserving length and angle measure leads us to the word congruent. So when we're preserving our length and our angle measures, we can compare two different figures by how they were moved or transformed using this rigid motion. So congruent figures can be obtained or created from rigid motions. When we're looking at congruent figures have the same size and the same shape. So our next word that we're looking at is called a congruent figure. So basically, oh my gosh, I can't spell today. A congruent figure, or two congruent figures, that is a G, and that's a U. So congruent figures have the same shape and same size. Okay, so they are the same. It's like they match. They might look different, like be in different parts of our quadrant, or one might be translated, one might be reflected, one might be rotated. So the shape is pointing a different direction. However, it can still be congruent, have the same shape and the same size as another figure in the coordinate plane. So congruent figures are some figures that we're going to identify today. We are looking for things that have the same size and the same shape. All right, so this is going to take us back to thinking about kind of like towards the middle of the year when we looked at angles of triangles. Were they the same angle measures? When we looked at angle measures of lines in a square, those types of things. So I'm going to show you a couple different figures in a plane, and we're going to talk about the things that are congruent. So I'm going to move this up, hit pause right now if you need more time to write down the vocabulary, but we're going to start looking at a figure that looks like this. Okay, so we have this shape right here. You can see in the graph you have 5 different triangles, and our job is going to be to identify triangles that are the same within this coordinate grid. And we're going to talk about why they are congruent, like what has happened to them in order to make them congruent, or their rigid motions that have happened. Okay, so first we're going to take a look at a triangle, and the first triangle that we're going to look at is triangle D, E, and F. So let me get my pen. All right, so example A, we are going to look at triangle D, E, F. So when I look at this paper right here, or this picture, I can see triangle DEF is right here. So DEF. Okay, so this triangle here. My job is to identify which triangle here in this area is congruent, has the same shape and the same size. Well, I know it's kind of a smaller triangle, so I'm going to look at another triangle that's also a smaller triangle right here. So I'm looking at triangle MNP. This triangle is congruent, and the reason why they're congruent is because it's 1, 2, a 2 by 2, here's a 2 by 2, and they have the same shape. They're both right triangles. So I would say that triangle DEF is congruent. They use this little symbol right here for congruent. Oh, you can't see it. It's underneath my, I'm a single ender. Okay, it's congruent to triangle MNP. Okay, so triangle DEF is the same as triangle MNP. The differences between these two triangles, the way that it was created, was a translation. So the type of rigid motion that was created from this triangle right here, so we can talk about the rigid motion. The rigid motion that we can see from this example is that this triangle went up 1, 2, 3, 4, 5, and over 1. So the points on this triangle have moved so to the right, 1, and up 5. That is how we describe the rigid motion that has occurred. So the rigid motion is a translation. That's how we were able to create that congruent triangle, was through a translation of 1 unit to the right and 5 units up. Now, if you want to draw this picture right here on a sticky note, you're welcome to. Or if you want to take a screenshot of it and put it into your into a Jamboard, you're welcome to do that too. Whatever's going to help you with your notes. Okay. All right, we're going to look at another congruent figure within this same picture. So hit pause right now if you need to finish writing this down. Otherwise, I'm going to move it up. All right, so the next example that we are going to look at is using this same exact picture. So you can use the same picture here. And within this picture, we're going to look at example B. And example B is going to come to us from triangle ABC. So let me get a new color. There we go. So we're going to look at triangle ABC. So here's triangle A, B, C. Again, you notice it's a right triangle. Our job is to identify within this picture a right triangle that is congruent to triangle ABC. So we have 1 unit, 2 units, 3 units. So a 3 by 1, 2, a 3 by 2. Well, let's look at PQR. So there's by 2, but this one is by 1, 2, 3, 4. So that one is not congruent. Let's look at another one. Let me change colors here so that we can see it a little bit better. Here's another one that's by 2. And this one is also, so we get by 2 here, and then 1, 2, 3. This one is congruent. It just doesn't face the same direction. So the rigid motion that occurred here was a different type of transformation, not a translation like we saw in this first one. So let's go ahead and talk about the rigid or the triangles that we see. So we have triangle ABC, and triangle ABC is going to be congruent to triangle JKL. And now we're going to talk about the Y. So they have the same angle measures. They're both right triangles. They're a 3 by 2 or a 2 by 3, right? So the base is 2 and the height is 3. And we're going to talk about this rigid motion. So our rigid motion is not a translation. Is it a rotation? Did it rotate? No, it's not a rotation. However, if you look, it is a flip or a reflection. So we're looking at this one here as this triangle has reflected over the x-axis. So the rigid motion that we see here is a reflection in x. So it's a reflection in the x-axis. Okay, and when it's reflecting in the x-axis, we know that the angle measures, so angle measures are congruent, and the side measures. So our sides are the same. So side AB is equal to or congruent to side JK. We use that little line over the top to talk about the line segment. And the line segment of, which one did we do? CA is the same or congruent to LJ. J. So that's how we know it's just a reflection. The measurements have remained the same. The side lengths are the same. The only rigid motion is that it became a reflection. So those are congruent. They're the same triangle or the same size, same shape. The only change is that it was reflected over the x-axis. Okay, it is going to be your turn now to do a try it. So either hit pause right now so you can finish getting these into your notes. I'm going to turn the page and we are going to look at the next, or your try it example, I should say. All right. All right, so we are going to be looking at a triangle. Triangle is called XYZ. And triangle XYZ has vertices of X being 0, 4. Y is 4, 4. And Z is 4, 2. Our job is to determine, are there any triangles within the picture we just used? So I'm going to erase all of the lines here so that we can see it a little bit better. If we're using this exact same figure, they want to know, are there any triangles that are congruent, and to explain. All right, so first you're going to need to graph this triangle, and then you're going to need to tell me, are there any congruent figures in this graph over here? Okay, so go ahead and hit pause right now so you don't hear me explaining, and then when you are ready to check your answers, come on back, hit play, and then we will go from there. All right, so I'm going to go ahead and graph this first. Oh no. Where did it go? There it is. Okay, so we're going to go ahead and graph this triangle right here. Okay, so triangle XYZ. So I'm looking for X at 0, 4. So here's 0. I'm going to go up to 4, put a dot, and that is X. All right, now I'm going to go over to Y, which is 4, 4. So over to Y, 4. And then up to 4 and put a dot. Ooh, this is going to get kind of messy. And then I'm going to get 4, 2. So I'm going to go over to 4, up to 2. All right, so I'm going to connect my dots here. Oh, you know what? I'm going to use that trick. So let's use the trick. We're going to go from here to here. There we go. Here to here. And there to there. All right, so first, our job is to identify, do we have any triangles here that match this triangle XYZ? Well, I see that triangle XYZ is a 2 by 1, 2, 3, 4. Okay, I had a 2 by 4 over here from before. So I know that this triangle right here is, oh, that is not my highlighting tool missing letter. There we go. All right, so I've got highlighting happening. It gives me a 2 by 4. This triangle over here is also a 2 on the base, by 4 on the height. So this tells me that these two things are congruent. So yes, my answer is yes, they are congruent. Yes, triangle XYZ is congruent to triangle PQR. All right, now we have to explain the y. Well, the y is we have triangle XY is congruent to QR, and YZ is congruent to PQ. Also, the rigid motion. What is the rigid motion that occurred? Well, the rigid motion that occurred in this happens to be a rotation. So if you look, we've started here and we have rotated, right? So it's like it's just going around in a circle. So if we're starting in this quadrant and we're rotating this direction, it is a rotation that's counterclockwise 90 degrees. So rotation, counterclockwise 90 degrees. All right, it is time for us to now answer our essential question. How do we identify congruent figures? How do we identify congruent figures? So go ahead and answer your essential question and put your level of understanding out to the side. Where are you at with your level of understanding? One, I have no clue what any of these vocabulary words mean, and I'm going to go back and rewatch the video until I understand. 2, I kind of starting to understand. I understand that triangles and shapes are moving. They have to be the same, but I'm having a hard time seeing what the movement is. Or maybe you're at a 3 where you understand it, you're ready for more practice and ready to apply it. So go ahead and rate your level of understanding. And then when you are finished, you can come on back to the Google Meet and ask for help if you need it, or you can go on and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.